The next three questions, they are pertaining to the greatest integer function and similar concepts. So first they define greatest integer function. So we know the greatest integer function. So then they define the fractional part of x, or the decimal part of x. So x minus greatest integer function of x is basically sometimes represented as curly bracket x, which is basically fractional or decimal part of x. So the decimal part of x, if for example let's say x equals to 1.5, then decimal part of x is 0.5. If x equals to 1.7, then decimal part of x is 0.7. Now if x equals to minus 1.7, then greatest integer function greater than or equal to x is, so curly square bracket x is greatest integer that is less than or equal to x. So slightly less than x, the greatest integer is going to be minus 2, which implies that curly bracket x is just minus 1.7 minus 2, so that is 0.3. Alright, so for the negative part is going to be the thing that you have to add to make it an integer, add or subtract to make it an integer, sorry, so subtract. So it's not the visible part, it's not the 0.7, it's going to be the remaining part, the complementary of it. Now the point is, how do I plot this function? So the way to plot this function is that if let's say this is your x-axis, then the greatest integer function of any integer, the decimal part of any integer is going to be 0. So if I start from 0 and let's say this is 1, this is 1, 2, 3, 4 and so on. Okay, so my function is going to look like this. Alright, so when it reaches a value 1, so I know that the integer part of 1 is equals to 0. So at 1 it suddenly drops to 0, but the integer point of 0.99 is 0.99. Okay, so that's why there's a discontinuity. So if you look at the discontinuity, so from the options, so it is actually left discontinuous at all the integer values. Okay. Now let's look at the second part of this problem. So question number 42, wait, this should have been 42. Yeah, so if I look at question number 42, so they define this new thing now as the smallest integer that is greater than or equal to x. So the smallest integer, so they define it like this. Smallest integer that is greater than or equals to x. So suppose I want to define the smallest integer of 1.7, the smallest integer that is greater than this, so there is going to be 2. Okay, and smallest integer of minus 1.7, so smallest integer which is greater than minus 1.7 is minus 1. Alright, so 1.7 minus 1.7, this is going to be 1.7 minus 2, so that is 0.3, right? And this part is going to be minus 1.7 minus minus 1, right? So minus 0.3. So this is going to be minus 0.7. So it's always going to be negative, and it's going to be the part that you do not see. So now it's going to flip itself. So if we draw it for any value of x, so at the integer value it's going to be 0, at 0 it's going to be 0, because the smallest integer of 0 is 0. Smallest integer greater than or equals to 0 is 0. But as I proceed in the other manner, it's going to suddenly drop. So 0.1 minus the smallest integer 0.1 is going to be 0.1 minus 1, so that is minus 0.9. So as soon as you move to the right of 0, you are going to drop down here, and then what you're going to see is something like this. And so on it goes, right? So it proceeds in this manner, and yeah, so what we see is right discontinuity. So it will be continuous here at any integer, it's discontinuous to the right. To the right it drops here, so it's going to be right discontinuous at any integer value. Okay. Alright, now finally the last part of this problem, question number 43. So in this problem we again come back to the original definition, and we define the function, new function, that is greatest integer minus smallest integer. Okay, so now greatest integer function of x minus, no sorry, the smallest number greater than x minus the greatest number smaller than x. Okay, so let's do this with an example. So for for integer values, both these will be equal to x, and so that will cancel out. Let's take for 1.7 minus minus 1.7, right? So the greatest integer, which is the smallest integer greater than, yeah, the smallest integer greater than x, sorry, this minus this. The smallest integer definition looks like this, and this looks like this, right? Yeah, smallest integer, greatest integer. So now the smallest integer greater than 1 by 1.7 is 2, and the greatest integer smaller than 1.7 is 1, so that is going to be equal to 1. But for 1 it is going to be 0. So at all integer values this is going to be 0. So if I were to plot this function, so at all integer value it's going to be 1. Sorry, it's at all integer values it's going to be 0, and at all non-integer values it's going to be equal to 1. So it's going to look like this. So at any integer value it's discontinuous to its right and to its left, so it has a discontinuity on both sides to an integer. So left and right discontinuous at any integer. Okay, so that wraps up these three problems.